a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9, we have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2,
perseverance.
launch commit, liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Buenos días tengan todos. Gracias por estar con nosotros en esta mañana un poquito lluviosa para transmitir y retransmitirles a todos ustedes un momento histórico que va a estar pasando el día de hoy en este tema de exploración espacial que tanto nos encanta a todos nosotros. Mi nombre es Natasha de León. Estamos aquí en el Ecoexploratorio Museo de Ciencia de Puerto Rico junto al doctor Geraldo Morel, colaborador del museo y gran amigo de todos nosotros, Henry Rivera, nuestro gerente de exhibición, y nuestra educadora Lorna Soto. Cuéntame, doctor, ¿qué estamos viendo y qué vamos a ver en unos minutos que va a estar, ¿verdad?, sucediendo allá en NASA?
Natasha, buenos días a ti, a toda la audiencia del Ecoexploratorio. Dándole seguimiento a lo que vimos a través de ese video de NASA, somos una especie de exploradores. Los seres humanos somos exploradores por naturaleza. Y hoy vamos a estar viendo el lanzamiento de la misión más importante de exploración de Marte. Se trata del Mars 2020, que va a ser lanzado desde el Cabo Cañaveral en la Florida. Y a bordo de esa misión, de ese cohete, va el rover Perseverance, que es el rover que tiene más tecnología avanzada que ningún otro rover que se haya lanzado anteriormente. Esta misión tiene la particularidad que va dirigida a buscar rastros biológicos en la superficie marciana. Es decir, va específicamente a buscar rastros de vida, de que hubo vida, si hubo vida o no, en un pasado lejano en el planeta Marte. Sabemos que el planeta Marte albergó agua y albergó una atmósfera parecida probablemente a la de la Tierra hace millones de años. Así que existe la posibilidad de que también albergara vida. En adición a esa parte, ese objetivo de buscar rastros biológicos, también se va a probar nueva tecnología en la superficie marciana. En particular, se lleva un helicóptero. Es la primera vez que los seres humanos van a probar una nave aérea fuera del planeta Tierra. Y esa prueba tecnológica será uno de los objetivos más importantes de esta misión, en adición a la parte de buscar señales biológicas en Marte. También tenemos en esa misión de Mars 2020 una sonda meteorológica. Comienza con esta misión la meteorología marciana. Llevamos un dispositivo para medir presión atmosférica y también vamos a medir velocidad y dirección del viento en el planeta Marte. Y todo esto lo estamos haciendo en preparación a la llegada de seres humanos eventualmente a la superficie marciana. Así que toda esta investigación robótica nos permitirá allanar el camino para enviar seres humanos de forma segura a Marte en un futuro no muy cercano.
Estamos viendo en pantalla a un estudiante que tuvo un rol bien importante en este proyecto de Perseverance. Lorna, ¿me puedes hablar un poquito de dónde salió el nombre de Perseverance? Y cómo los niños, ¿verdad? Y los estudiantes tienen un rol súper importante en estas misiones.
NASA lo que hace es que, gracias Natacha, que cada vez que hay una misión, le hacen un llamado a estudiantes a nivel internacional, especialmente en los Estados Unidos, para que le den un nombre, ya sea al rover, ya sea a otro de los instrumentos importantes. Entonces hacen esa convocatoria, ellos someten no solamente un nombre, sino tienen que escribir un ensayo. Pueden ser estudiantes usualmente de escuela intermedia superior. En este caso, luego de mucho análisis y hacer evaluaciones, pues fue escogido, él está en escuela intermedia, este joven. Y con apenas 13 años, si él lo dice, explica muy bien en un video que pueden conseguir en el canal de YouTube de NASA, que él no esperaba que fuera escogido y mucho menos hacer esa contribución tan joven. Pero sí, él quiere seguir una carrera en el área de aeroespacial. Igual ocurre con el helicóptero, con Ingenuity, que fue un estudiante de escuela superior. Así que las oportunidades para los chicos y los jóvenes en el área de STEM son infinitas. Por ejemplo, ponerle un nombre a un rover. Esa es la historia detrás.
Sí, es súper interesante. Así que niños que nos están viendo, ustedes pueden tener su huellita, ¿verdad? Poner su huellita en estas exploraciones espaciales que salen a explorar lo que no conocemos todavía. Gerardo, cuéntame, nosotros salimos hoy, ¿verdad? Sale este rover hoy, pero ¿cuándo llega a Marte? ¿Qué es lo que se espera?
Mira, la travesía a Marte es una travesía muy larga. Cerca de 7 meses aproximadamente, 6 meses y medio, casi 7 meses. Este rover en particular estaría llegando específicamente el 18 de febrero de 2021 a la superficie marciana. Así que es una trayectoria de aproximadamente 6 meses y 3 semanas. Durante esa trayectoria, pues entonces estaremos también monitoreando el progreso, ¿verdad?, del acercamiento a Marte, y luego entonces cuando llegue a la atmósfera marciana y eventualmente cuando haga el amartizaje.
Así que amigos, nos van a ver en febrero de nuevo hablando un poquito sobre Perseverance y su llegada al suelo marciano o de Marte. Henry, cuéntame por qué exploramos, cuál es esa importancia de nosotros explorar el espacio.
Primero que todo, muy buenos días a todos y gracias por estar conectados a través del Eco Exploratorio. Nosotros, como mencionó el doctor Gerardo Morel, somos una especie curiosa, una especie de exploradores. Y a través de los siglos, pues nosotros hemos explorado todo nuestro planeta y es hora de explorar las estrellas, de explorar el resto de nuestro sistema solar, que es nuestros vecinos más cercanos, como lo es el planeta Marte. Pero es bien interesante que no es solamente porque apela a nuestro instinto de explorar y de expandir nuestros horizontes, sino porque también a través de la exploración espacial, grandes avances tecnológicos surgen que nosotros no tenemos idea al momento. Nosotros no pensamos, vamos a ir a Marte porque vamos a construir vamos a crear nuevos avances tecnológicos, sino porque esos avances tecnológicos surgen y percolan se van colando a través de la sociedad y van ayudando no solamente pues lo lógico que uno pensaría, nuevas tecnologías para cohetes o robots o astronautas, sino que también se crean avances tecnológicos que ayudan a las comunicaciones en nuestro planeta, a la medicina, a la ingeniería y a diferentes otras áreas de la ciencia y de nuestra sociedad. Así que la exploración espacial es más que nosotros meramente explorar, sino que nos beneficia grandemente a todos nosotros, no solamente que estamos conectados al tema de la exploración espacial, sino a toda nuestra sociedad.
Quiero dar un saludo a todos los que nos acompañan el día de hoy a ver esta transmisión tan importante. ¿Qué está pasando en estos momentos allá en NASA, que está ocurriendo, verdad, con el cohete? Entiendo que estamos a 4 minutos del lanzamiento, a 2 minutos del lanzamiento. En realidad estamos a 2 minutos de que salga el Perseverance hacia Marte. ¿Qué están haciendo ahora mismo los ingenieros allá? Cuéntame, Lorna.
Bueno, esto ha ocurrido en muchas ocasiones. Yo creo que el doctor Morel tiene vasta experiencia en podernos describir este suceso. Estamos apenas a 2 minutos. Ya ellos hicieron la prueba de lo que tiene que ver con energía, además, hicieron la prueba de meteorología, de las condiciones atmosféricas, pero esto es bien importante, doctor Morel. Usted nos puede explicar ahora mismo que ellos están probando. ¿Qué se debe estar sintiendo allá en Cabo Cañaveral, todos ellos que están ahora mismo muy pendientes?
Securing Centaur LO2.
Sí, en este momento están verificando también que los sensores de combustible.
Launch conductor sequence is ready to go. They're getting ready to turn the vehicle over to autopilot at minus 31 seconds. So that's a big thing that they're getting done here. At T minus 25 seconds, we will hear the team give their final goes that everything is ready and the launch vehicle is ready to lift off and perform this mission.
SCS count started.
1 minute 15.
Produce CCS for launch. Roger.
1 minute 10.
Y este es un gran equipo que está trabajando con este gran lanzamiento, porque no es solamente, nosotros siempre pensamos en que los lanzamientos de NASA son Kennedy Space Center y en Cabo Cañaveral en la Florida, pero el rover como tal está a manos de JPL, que es el Jet Propulsion Lab, que se encuentra en California, que ellos construyeron, estuvieron por mucho tiempo, muchos años. Es una misión que lleva en construcción casi 10 años entre concepto y la construcción del equipo. ¿Cómo es esa colaboración entre las diferentes organizaciones de NASA?
Ready to go. And here at about 5 seconds, we will hear the team.
En el JPL ellos suelen construir, se mantienen en comunicación directa para entonces poder desarrollar las tecnologías y que vayan acorde con ese timeline, con ese tiempo que ellos perciben, ¿verdad? Que puede durar esa misión, y ya estamos a ¿cuánto? 15 segundos. Esto no lo podemos perder.
8, 7, 5, 4, engine ignition, 2, 1, 0. Release and liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU is on a closed loop control. Coming up on 30 seconds into flight, the RD-180 is throttling down as expected. Engine response looks good. And Mach 1, Atlas V is now supersonic. And passing 45 seconds into flight, vehicle is now passing through max Q, maximum dynamic pressure. And passing 1 minute into flight, the RD-180 is throttling back up as expected. Engine response looks good. At this time in flight, the SRB chamber pressures remain nominal. The RD-180 pump speed and fuel injector pressures are responding well to demands on the engine. Standing by for SRB burnout shortly.
Todo va bien hasta el momento, las presiones de los combustibles y todo está saliendo bien.
And we have burnout on all 4 SRBs. Burnout pressure signatures look good. Standing by for SRB jettison shortly.
Una de las partes del cohete va a ser desprendida, como se anticipa. Ahí la tienen.
And we have a good indication of SRB jettison of all 4 SRBs. And the vehicle has gone to closed loop guidance.
Lo que vimos ahí fueron como si fuesen los boosters, los cohetes secundarios que se encuentran alrededor del principal,
Exacto.
que fueron desprendidos.
Sí, análogo, ¿verdad? A los otros cohetes que se usan para la estación espacial, pero esto es un cohete mucho más potente.
And coming up 1.5 minutes into flight, the RD-180 is throttled down slightly as expected. Engine response continues to look good. At this time, the vehicle is 50 miles in altitude, 85 miles downrange, traveling at 6,000 miles per hour.
Ya va a 6,000 millas por hora. A
And
50
the Centaur
millas.
reaction control system is now pressurizing to flight levels.
Aquellos que estamos acostumbrados a los lanzamientos de SpaceX, esto es un poquito diferente porque el cohete no es solamente el main stage y el second stage, sino que tiene los boosters alrededor como
The RD-180 is now
los
throttling
controladores espaciales.
2.5 G acceleration limit for payload fairing jettison. Engine response and vehicle acceleration look good. And we have good indication of payload
Yo sé,
Centaur 4.
tenemos que comentar esto, Henrik. Se tuvo la oportunidad de verlo en la ventana. La prioridad que teníamos, ¿hasta qué fecha, Henrik? Si no ocurría hoy.
Teníamos hasta el 15 de agosto. Estábamos ahí con los deditos, mira, cruzados para que no pasara nada, como vimos hace poquito en junio con el lanzamiento del de SpaceX, que se vio retrasado un poco, que por cierto, esta semana es una semana de exploración espacial, porque el sábado es que los astronautas en la cápsula Dragón se desconectan de la Estación Internacional Espacial y el domingo es que regresan. Después de casi 2 meses estuvieron en el espacio. Desde mayo. 2 meses, sí.
Próxima fase del cohete se separa.
And we have good indication of Atlas Centaur separation.
Todo salió bien hasta ahí también. Prendió el cohete.
We have the Mach 1. RL-10 operating parameters look good. Chamber pressures are stable.
Eso que estamos viendo ahí es la parte trasera de la segunda fase, que sería como un cohete más pequeño. ¿Cuál es la función de ese cohete?
Ese cohete va a terminar de acomodar en órbita
footage there. That's video. We will see that switch over shortly.
la carga del cohete, que en este caso es el Perseverance.
Let us know what's happening with the rocket, but right there, a beautiful liftoff. Fun to feel that rumble.
Tiene la capacidad de maniobrar, por lo tanto, no solamente es, no es tan potente como las primeras fases, pero tiene la capacidad entonces de maniobrar y completar el posicionamiento en órbita, porque la nave tiene que entonces acomodarse para seguir su camino a Marte. Y están indicando que las presiones están bien, que la velocidad alcanzada también, como pueden ver, 14,000 millas por hora. Y ya está a 400 millas de altura. Todo ha ido saliendo perfectamente bien. Esta es la fase más, siempre como con los aviones, el despegue es la fase más crítica, en que si sucede algo, que no estuvo planificado podría causar abortar la misión, y hasta la fecha pues todo ha ido según planificado por los ingenieros.
Y los niveles de tensión vuelven a subir dentro de unos mesecitos más, porque me gustó mucho esa analogía, doctor. Es como cuando uno viaja en un avión. Lo más difícil y lo que más da miedo es el despegue y el aterrizaje. Y cuando en febrero 18 veamos esa reentrada del rover, va a ser, le llaman los 7 minutos de terror.
It's tough to make out, but that engine is lit. It's firing. So we are in motion. There you go. There's that animation we talked about.
The telemetry there as we switch to a TDRS compatible data format.
TDRS.
Overall telemetry quality is very good.
The space tracking system. So there you go. This is not an actual video, but this is an animation that's driven by real data. So although we're not actually seeing the engine on screen right now, we can see.
Estamos viendo una animación que se alimenta con datos reales.
Yeah, the launch vehicle continues
en ese sentido es una animación que refleja exactamente lo que está ocurriendo en este momento.
Esto es bastante innovador. Yo no lo había visto con tanta frecuencia, para entonces que pudiéramos ver también información adicional que les permita a ellos poder recopilar y mostrarla a nosotros. Esto no es lo usual, por lo menos no lo había visto en misiones anteriores con tanto detalle. Me parece excelente.
Sí, esta es la magia de Computer Science, que como si fuera una imagen real, se nutre de datos reales, pero es fabricación de la computadora.
Me encanta porque volvemos a lo que estamos acostumbrados recientemente, el de SpaceX, que en SpaceX pues ellos utilizan unas cámaras de mayor, a lo mejor de mayor definición para poder capturar ese momento, que nos permite cómo va a caer. En un momento vimos cuando se conectaron los fairings, que es el cono, la punta del cohete, donde adentro pues protegía lo que ahora vemos que parece como de ese cohete, que es el elemento
Ya habíamos mencionado cuánto tiempo tomaba llegar, pero nos están volviendo a preguntar personas cuánto tiempo es que nos toma llegar de nuevo desde que salimos de hoy a llegar a Marte.
Casi 7 meses toma en llegar a la superficie de Marte. Va a llegar específicamente el 18 de febrero del 2021. Y volviendo a lo de la ventana, hoy es un día histórico para este Mars 2020, que si la ventana no podíamos utilizarla entre ahora y el 15 de agosto, que era esa ventana iba como desde hace 2 semanas hasta el 15 de agosto. Si no hubiéramos podido lanzar por alguna razón técnica o alguna razón del clima, habría que posponer el viaje por 24 meses por 26 meses, o sea que son más de 2 años, para volver a lanzar la nave, entonces a tratar de lanzar la nave en ese momento. Así que era muy importante que se pudiera lanzar en esta ventana de oportunidad. ¿Y por qué es que hay una ventana de oportunidad? Pues porque la posición relativa entre Marte y la Tierra cambia continuamente. Hay momentos en que estamos más cerca, los dos planetas, y hay momentos en que estamos mucho más lejos. Así que se calcula cuándo es que los dos planetas van a estar en sus puntos más cercanos y se busca esa ventana de oportunidad para el lanzamiento, de manera que el vuelo tarde eso de 6 a 7 meses. Si la dejamos pasar y tratamos de lanzar, pues ya tardaría demasiado y la misión no fue diseñada para tardar tanto en llegar, por una serie de razones de ingeniería también. Así que esa ventana se pudo cumplir hoy, del lanzamiento 30 de julio del 2020, y entonces estaríamos alcanzando la superficie marciana el 18 de febrero del 2021, que también entonces estaríamos transmitiendo ese amartizaje de el rover Perseverance, que lleva el helicóptero Ingenuity a bordo también, sobre el su aterrizaje sobre el planeta Marte, o su amartizaje, que es como se dice en español, ¿no?
El rover siempre está en comunicación, ¿verdad? Con NASA y con los científicos que están acá en la Tierra. ¿Cuánto tiempo tarda esa comunicación? ¿Eso es algo directo? ¿Estamos conectados como aquí en Puerto Rico?
Mira, según se va alejando, pues la comunicación va a ir tardando más. Ahora mismo todavía está muy cerca y la comunicación es casi instantánea, casi como nosotros acá entre los celulares. Pero según se vaya alejando, la comunicación va tardando minutos en lo que llega la señal al rover y regresa a la Tierra varios minutos más. Finalmente, cuando esté sobre la superficie marciana, va a tardar al menos 6 minutos en la posición más cercana entre Marte y la Tierra. La comunicación tarda 6 minutos. O sea que tú le dices algo al rover, le das una instrucción, por ejemplo, y esa instrucción le tarda 6 minutos en llegar. Entonces, el rover hace, ¿verdad?, lo que la instrucción decía, y nos tarda luego 6 minutos en decirnos qué fue lo que hizo, si lo hizo bien, o qué fue lo que vio en la nueva posición. O sea que la comunicación después es bien lenta, y lo más rápido que puede ser es 6 minutos. Cuando Marte y la Tierra estén en sus puntos más lejanos, la comunicación va a tardar hasta 14 minutos one way, ¿verdad?, por cada vía. Así que podría tardar 14 minutos en la posición más lejana, en lo que tú le dices algo al rover y ese mensaje le llega al rover, y luego 14 minutos más en lo que regresa la contestación del rover acá a Jet Propulsion Lab en California.
Y el rover está, ¿verdad? Él tiene sus instrucciones. Tenemos personas en NASA que le dan instrucciones, como quien dice, el que guía el robot en este caso. ¿Cómo funciona eso? ¿Eso es instrucciones diarias? ¿Él sabe hacia dónde moverse, cómo explorar?
Sí, mayormente tiene un sistema autónomo, tanto el rover como el helicóptero Ingenuity, que se va a demostrar la tecnología en Marte. Ambos tienen sistemas autónomos, o sea, ya tienen programada una serie de instrucciones para que las lleven a cabo sin necesidad de intervención humana. Pero la intervención humana va a hacer falta en algunos momentos ya para hacer correcciones en la trayectoria, para verificar qué fue lo que consiguió y traer esos datos acá a la Tierra, y para verificar también si el sistema autónomo está funcionando. Y si no estuviera funcionando según planificado, pues habría que pasar a manual mode, ¿verdad?, a manejarlo manualmente, con esa dificultad de minutos entre la comunicación en cada vía. Pero sí se ha tratado de diseñar lo más autónomo posible, tanto el rover como el helicóptero Ingenuity.
¿Cuánto tiempo va a durar esta misión?
Lo que suele suceder es que, aportando un poquito a lo que dice el doctor Morel respecto a la programación, ellos se alimentan, usualmente los rovers, de toda esa información que ellos van adquiriendo. Por eso es que pueden funcionar de forma autónoma. Cuando se hace ese plan, se va viendo qué es lo que va ocurriendo diariamente, entonces se decide si va a permanecer tal cual con esa programación, si tiene la capacidad, dependiendo del área donde se ubique. Si no, pues entonces las correcciones. Quiere decir que así mismo los programadores le envían entonces esa información. Pero entonces funciona, ahí tenemos un principio también de lo que es inteligencia artificial, que le permite entonces, con toda esa serie de cámaras, esos instrumentos. Y Ingenuity tiene una particularidad, que si bien le va a enviar información a Perseverance, también necesita de todos estos orbiters que están alrededor algunos que están alrededor de Marte, para entonces poder trabajar. Así que esto que tiene que ver todo con ciencias de computación, inteligencia artificial, algo que hemos estado enfatizando, los jóvenes tienen que empezar a adiestrarse, porque definitivamente va a hacer falta en esta misión y en todas las que están por ver.
Nos están preguntando en Facebook cuánto tiempo va a durar la misión, cuánto tiempo el rover va a estar en Marte.
Mira, el rover se planifica que esté por lo menos 1 año, pero la experiencia de NASA con rovers anteriores es que han estado por periodos muchísimo más largos que los planificados. Así que estamos anticipando que Perseverance también va a lograr rebasar las expectativas de NASA y va a poder mantenerse explorando el planeta Marte más allá de ese periodo inicialmente dentro de los objetivos de NASA. Hay cosas que no se pueden anticipar y son cuestiones meteorológicas también, como aquí en la Tierra con este fenómeno que tenemos hoy sobre Puerto Rico. Y es que allí ocurren tormentas de arena, ¿verdad? O de lo que sea ese polvo marciano que hay sobre la superficie marciana. Y eso ha demostrado ser bien dañino para los rovers. Si tenemos la suerte de que no ocurra una de esas tormentas en la trayectoria del Perseverance en un futuro cercano, pues el Perseverance podría seguir trabajando por un periodo bastante largo mientras sus baterías también lo permitan.
Doctor Morel, en este caso el sistema de energía y cómo se está produciendo en Perseverance en esta misión cambió un poco. No, hay sí unos componentes de que se va a nutrir de energía solar, pero en este caso parte de la misión incluye probar otras formas de hacerlo. Así que yo creo que esto es algo bien importante que debemos puntualizarle a quienes nos acompañan, que le damos las gracias a todos por acompañarnos tempranito en la mañana. Que si puede abundarnos ahí un poquito y explicar eso.
Claro. Gracias por mencionarlo, Lorna. Hay un crecimiento en la resiliencia de esta misión marciana del Perseverance debido a que la batería principal del vehículo es una batería nuclear. Básicamente trabaja con isótopos radioactivos. Es una batería que se anticipa que pueda durar por periodos de años si el rover así pudiera seguir funcionando también. En ese sentido, esto es una misión que tenemos la esperanza de que sí pueda seguir explorando la superficie marciana mucho más allá de un año. Los sistemas accesorios, ¿verdad? O colaterales del rover, algunos de ellos dependen de energía solar y esos son los que son un poco más frágiles. Y también el problema de las tormentas de arena es que tienden a dañar los sistemas mecánicos. Así que en algún punto podría ocurrir que la arena dañe los sistemas mecánicos y que el rover, aunque esté en comunicación con la Tierra, pero no pueda seguir, ¿verdad?, moviéndose según las instrucciones que tenga de JPL. Por esa razón es que de todo, ¿verdad?, los posibles efectos que pueda haber dañinos sobre el rover, probablemente del polvo marciano es uno de los que más podría causar daño a la misión, pero que también se ha mitigado, ¿verdad? Se ha mitigado a través de la batería nuclear, pero también se ha mitigado a través de sistemas del uso de materiales que son más resistentes al polvo marciano y que tienen menos adhesión del polvo marciano. También se han ido creando dos tolerant bearings. Hasta donde se ha podido hacer, ¿verdad?, que es las cajas de bola de los sistemas mecánicos, tratar de hacerlos sellados o semisellados o con materiales que sean más tolerantes a tener arenilla entre los sistemas mecánicos y que aún así no se tranquen, ¿verdad? Esos son algunos de los avances mecánicos de ingeniería mecánica que se han hecho en esta misión y como dijo anteriormente Henrik, muchos de esos avances que se desarrollan para las misiones espaciales eventualmente tienen aplicaciones aquí en la Tierra, así que todos esos adelantos en la ingeniería mecánica terminan teniendo un impacto en los automóviles y en los aviones y en otros vehículos de carga pesada que se utilizan en la construcción. Así que en ese sentido es que NASA tiene estos spin-offs que se beneficia la vida aquí en la Tierra y la calidad de vida de nosotros aquí en la Tierra de los avances tecnológicos que se hace para la exploración de Marte y para la exploración de la Luna, para la Estación Espacial y otros proyectos de la NASA.
En esa misma dirección, acerca de los spin-offs, tenemos que mencionar que en este caso se ha ido probando más o menos cómo podríamos hacer para dividir y darnos cuenta si podemos de verdad lograr que haya oxígeno. Y eso es una de las cosas también que va a estar haciendo Perseverance, y va a tratar de ese dióxido de carbono, dividirlo y que podamos tener la posibilidad de, aparte de estudiar esa vida que se supone que hubo alguna vez en Marte, si podríamos tener eventualmente también presencia. Y todo eso va ocurriendo con los años, poco a poco, con toda esa tecnología que se ha ido trabajando. Y esperamos que sí, que se pueda lograr y que entonces prontamente pueda haber algún tipo de presencia de vida allá en Marte.
Lorna, esa tecnología que tú mencionas es bien importante, tanto para esta misión a Marte como aquí en la Tierra. Se trata de demostrar el uso de una tecnología para descomponer el dióxido de carbono y obtener entonces oxígeno y carbón. Y eso, en medio de todas estas discusiones del calentamiento global y la producción excesiva de dióxido de carbono en la Tierra, podría tener aplicaciones aquí también para controlar el nivel de CO2 atmosférico a largo plazo, que nosotros podamos, nosotros mismos como seres humanos podamos, como quien dice, sanar la atmósfera de todo el dióxido de carbono en exceso que hemos estado emitiendo. Así que esa tecnología que se va a estar probando en Marte para producir oxígeno a partir del dióxido de carbono va a tener implicaciones importantes para la calidad de vida de nosotros aquí en la Tierra y para mejorar entonces todo lo que tiene que ver con el efecto invernadero aquí y los efectos antropogénicos del efecto invernadero, es decir, el CO2 que producimos nosotros los seres humanos, poder nosotros mismos encargarnos de reconvertirlo a oxígeno.
Estamos ya a puntito, ¿verdad?, de terminar la transmisión, pero tenemos una pregunta bien interesante en Facebook de ¿por qué Marte? ¿Por qué se escogió Marte?
Mira, esa es una pregunta que la comunidad científica tiene un debate bien grande. Hay científicos que dicen que, especialmente científicos europeos, que dicen que Estados Unidos le da demasiada importancia a Marte en el contexto de la búsqueda de vida fuera del planeta Tierra. ¿Verdad? Hay opiniones a favor y en contra y todo un debate acerca de este tema. La realidad es que a través de las investigaciones de la superficie de Marte que ha hecho los Estados Unidos, ya sabemos que hubo agua en abundancia en el planeta Marte hace millones de años. Y ya sabemos que Marte tuvo una atmósfera bien gruesa hace millones de años. Son dos condiciones que tenemos aquí en la Tierra que favorecieron el surgimiento de la vida. Y es por esa razón que Estados Unidos está enfocado en la búsqueda de rastros biológicos en Marte, porque se entiende que si hay un lugar probable en el sistema solar sobre el cual pudo haber habido vida, es la superficie marciana. En particular, este rover, el Perseverance, va a hacer amartizaje en el cráter de Jezero. Es un cráter que albergaba el delta de un río. Ustedes saben que el río donde sale al mar se crea un delta. En ese delta conviven múltiples especies, como el río arrastra sedimentos y se junta ahí el agua salada con el agua dulce. Los que estamos acá en la Tierra no sabemos en la Luna en Marte cómo era, pero haciendo la analogía con la Tierra de que esos deltas albergan una diversidad biológica enorme, pues estamos mandando el Perseverance precisamente a lo que era un delta hace millones de años en un río marciano que ahora está seco, pero que se anticipa que habrá fósiles de vida marciana, aunque sea vida microbiológica, en la superficie de este cráter que alguna vez fue el delta de un río. Así que por eso es que Marte es tan importante, porque en la búsqueda de los seres humanos de si habrá vida en otros planetas, el lugar donde más factible hubiera sido que surgiera vida que conozcamos hasta el momento es la superficie marciana, y en particular estas zonas donde alguna vez hubo cuerpos de agua. No sé si tienes algo más, Natasha, por ahí.
Yo creo que estamos, ahora nos toca esperar, sentarnos, esperar a febrero, ver cómo llega el rover Perseverance allá a Marte y aprender todo lo que nos va a estar enviando durante todo ese tiempo que va a estar, ¿verdad?, en Marte. Y esperar, nos toca esperar. Gracias a todos los que nos han sintonizado a través de Facebook, aquí en nuestro Zoom, al doctor Geraldo Morel, Lorna Salamán, Henrik, que estuvo conectado con nosotros. Doctor, algunas últimas palabras antes de irnos.
Bueno, para la juventud, mire, estas misiones a Marte no son el final de la exploración espacial, esto es apenas el comienzo. Lo que hay son múltiples oportunidades de aquí en adelante para los jóvenes que quieran dedicarse a estudiar ciencias, ingeniería y matemáticas para hacer contribuciones a la exploración espacial y a la calidad de vida de nosotros aquí en la Tierra desde diferentes ámbitos, ya sea que quieren participar directamente en una misión y montarse en un cohete, o que no les interesa montarse en un cohete, pero que quieren desarrollar esas tecnologías desde un laboratorio aquí en la Tierra. Así que hay oportunidades para todos. Hay oportunidades para el más extrovertido, hay oportunidades para el más introvertido y para todos los que están en ese abanico de posibilidades entre medio. Para todos ustedes hay oportunidades de desarrollo profesional en las ciencias, matemáticas e ingeniería. Y va a haber múltiples oportunidades tanto de la NASA como de compañías privadas que se están formando, como SpaceX y Boeing y otras que están surgiendo, porque el espacio es la frontera que va a seguir expandiéndose. Pueden hacer una analogía cuando se hizo el descubrimiento de América y los europeos empezaron a venir a las costas de América. Estamos en un periodo análogo. La nueva frontera es el espacio y los seres humanos estamos empezando a ir al espacio. Tanto los que van como los que nos quedamos y ayudamos a desarrollar tecnologías nuevas para apoyar a los que se van, todos nosotros estamos de alguna manera facilitando la exploración espacial, y va a haber oportunidades para esos jóvenes que también aporten en este proceso.
Sí, importante que de Puerto Rico a NASA, a Boeing, estamos allí ya. Tenemos muchos puertorriqueños trabajando en estos proyectos actualmente, así que el espacio es el límite. Sigan sintonizando al Ecoexploratorio Museo de Ciencia de Puerto Rico, donde vamos a estar dándole actualizaciones de la misión del Perseverance, cómo va a estar, ¿verdad?, cómo va su camino cuando llegue a Marte, y tenemos distintas actividades. Si están interesados en la exploración espacial, en la ingeniería y todos estos temas, no se olviden que para eso estamos aquí nosotros en el Ecoexploratorio, para ayudarlos a llegar a cumplir sus sueños. Gracias, Geraldo, gracias a todos los que nos sintonizaron en la mañana de hoy, se levantaron tempranito con nosotros para ver este momento histórico, y nos vemos en la próxima transmisión.
Gracias.
Gracias a todos.
Whether or not there was life.
Yeah, there's of course Pixel and Sherlock, the really amazing instruments that are going to tell us about the biosignatures. But in the middle, there is the coring drill. The real drill will have a drill bit, a coring bit, which is hollow in the middle. And there's going to be a tube inside. This is just a 3D printed version. And as it's collecting samples, it's going to have samples that go directly into the tube.
Oh, you've got a tube there. Yeah,
here's
show
a
that the camera
3D
there.
printed tube here.
Yeah.
And it's going to go down the middle of the tube as it's acquiring the sample. Once it's done, it's going to dock with the bit carousel here. It's going to ingest the entire bit with the tube inside and the sample. It's going to rotate down to the belly, and there's going to be a little arm on the inside called the SHA, the sample handling arm, to manipulate it, take pictures, assess the volume, and then seal it.
That's fantastic. And so there's quite a bit of robotics happening between this part, the bit carousel, and getting it underneath. As we know, it's now underneath. But here's a special guest, and we're going to duck down. This is the Mars helicopter.
Yes, Ingenuity.
Move. This thing is going to be actually tucked up underneath the rover. It was a late addition to this project.
Yes.
But it's probably one of the neatest things on it.
It is pretty amazing. 2,400 RPM that these blades are going to spin in counter directions.
Yeah.
It's a little bit under 4 pounds. It's super light. And yeah, it's going to be the first rotorcraft flight on the surface of Mars. It's spectacular.
And you know what's amazing? It will be taking pictures as well, right?
That's
Look
right.
At the blades.
Wow.
These blades turn,
Great
right?
model.
And they turn in opposite directions.
They
I
do.
understand.
They do.
It will have a camera on it. It will shoot live or shoot video.
Yes.
That we will then get back. It'll shoot video of the rover as it's doing its work, right?
Yeah, it's spectacular. And look at the clearance. I mean, this rover needs to clear this helicopter after it's deployed.
All right. Well, thank you so much for giving us the tour of the mock-up. It's just like the real one, except for it's not going to Mars. Well, thank you so much. And so by now you may have heard that this Perseverance rover was named by a 7th grader. And it was given that name, which is very special to us. And so we asked Hidden Figures actress Octavia Spencer to tell you why the Perseverance name is more than just a name to us here at NASA.
We are a species of explorers, believers.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
We are willing to do the hard things, to overcome the many challenges. This is what brings out the best in us.
We go for a mission to the moon.
Our path has led to success and to bitter losses.
We come together today to mourn the loss of 7 brave Americans.
Yet, even when faced with tragedy and setbacks, we persevere. We keep striving. We keep believing. From space, we see our planet as a whole. We see the challenges facing it, and we face those challenges together. We will not give up. We challenge convention. We refuse to accept the status quo. The time at hand is hard, but we will persevere. We can still draw hope from the moon and the stars, from space, from exploration. There is a new day beyond the challenges we face now.
Curiosity, insight, spirit, opportunity. If you think about it, all of these names of past Mars rovers are qualities we possess as humans.
10, 9. We have ignition sequence start.
But if rovers are to be the qualities of us as a race, we missed the most important thing.
3, 2.
Perseverance.
Launch commence. Liftoff. We have liftoff.
We are a species of explorers. We will meet many obstacles on our way to Mars. But as humans, will not give up. We will always persevere.
Our collective perseverance is what has gotten us to this day, and now Mars 2020 is on its 7-month journey to Mars with an anticipated landing date of Perseverance on February 18th, 2021. Now we are joined by Dr. Thomas Zurbuchen, Associate Administrator for Science at NASA. Dr. Z, thank you so much for coming over here.
God, I'm so glad I'm here, and I'm so relieved. You know, we have a space mission, and we're in touch with the spacecraft, you know, and everything is nominal. We're waiting, of course, for the second burn, but not quite there, but we're really close.
Yes. So can you tell us what makes going to Mars incredibly hard?
So there's really 2 pieces that make it hard. The first one is what we're doing today, which is you really need to head in the right direction. Yeah. So take it off the Earth and have a lot of energy and head exactly in the right direction, because what you want to make sure is in February, when Mars comes, you want to be right there so you can get captured. The second one which is the one that's going to make us nervous in February, is to entry, descent, and land. So the Mars atmosphere is almost the worst of all worlds. If it was really thick, you could do what we're doing on Earth, which just go in and with parachute. If there was none of them there, you could do, what we do at the moon. When in Mars, you have to do both on top of each other, which makes it 10 times harder than any of the other two. And so that's what makes it so hard.
Wow.
You've devoted much of your life to science. And I know you were asked the other day during a news conference, why another rover? And you gave a pretty impassioned response. Why is this rover important in your mind to the work that so many people are doing in science?
So it's really kind of a key of a whole bunch of new research that we're doing that is focused on a question that for thousands of years philosophers have asked, scientists have asked, and we're ready to answer with the tools of science, which is the way to get reliable answers. And that is there life out there? We have, for 20 years, we've learned about the environment at Mars, and we're ready to ask that now. And the way we're doing it is with this rover. So it's really, for the first time in decades, the first astrobiology mission. We're ready for it. It's the next step, and of course there's others coming. Dragonfly. We're already thinking about, and other missions. We want to, of course, go to Enceladus in Europa, and really learn about life there also. So it's an amazing first in that respect.
And whether there's life there or not, that's going to be the answer that we're looking for in these places.
Exactly.
Yeah, and so we want to do a social media question real quick, if that's all right with you.
Oh, absolutely.
All right.
We have a question from Twitter. What is the key difference between previous NASA missions, rover missions, to Mars, like Spirit, Opportunity, Curiosity, and Perseverance rover? In what way is Perseverance unique from the previous ones?
So there's a fundamental difference in the approach. And the fundamental difference is that we decided to put the instruments on Perseverance, the best geology instruments on this, so we can find the right samples. And we decided not to put a chemistry lab on it. Guess why? We don't know which one yet. And so what we're doing is we're actually collecting the samples that we're going to bring to the best labs that are available to humanity, which are the labs all over the world. And that's the choice here. And that's, of course, to do that, we need to do another first, which is humanity's first round trip to another planet. And that's what makes it different.
We've got more with the launch operation to go, but real quick, how'd you feel about that launch?
Oh, I loved it. It's like punching a hole in the sky, right? It's really getting off the cosmic shore, our Earth, into wading out there into the cosmic ocean. I just love it every time it gets me.
All right, very good. Dr. Thomas Zurbuchen, thank you for joining us. We appreciate you being here to explain all the science and the excitement that's coming up.
Thank you so much. Appreciate it.
Now we've talked to scientists and engineers, and we have shared highlights of the mission and tech demonstrations that are central to the Perseverance rover. And folks, we have a lot more to share.
Mars Perseverance has been flying in space for more than a half hour now. Let's check back in with Joshua and Mick to recap the flight so far and tell us what's coming up next.
Hey, thanks, Moo. Yeah, as you're seeing on screen there, that is, again, the animation of the Centaur in motion around Earth, in orbit around Earth. And you can see there, like I mentioned, the animation being driven by real telemetry data. Mick, how is the report coming back from the first burn and then currently our coast phase?
So we're hearing from Jesse Gonzalez and the engineering team is that everything so far has been nominal. Centaur's been performing well. All the settling firings have been going great, which is keeping the fuel that's still in the tank where it needs to be as we get ready to come up on main engine start 2 for that second burn, which is very important to get us our velocity and into that transfer orbit to Mars.
Yeah, so that will be up in just a few minutes, but I think we're going to actually send you back out to our main desk to hear. Oh, so sorry, I'm being held. We're going to hang out here. So coming up, so talk about C3, Mick. This is something that we talked about having to do with the energy to leave Earth and go somewhere else. We're talking about having to get to speeds over 25,000 miles per hour. That's Earth's escape velocity.
Yes, the C3 is basically just the technical term that we use in the aerospace industry to refer to the velocity that we need to get the vehicle where it needs to be. So as you said, we got that little over 2 million pounds of thrust that we left Earth this morning with those mighty 4 solids on the Dominator. I still like that from Tori Bruno. Tori, I'm gonna take that one from Tori. But we got off here and into the park orbit with the proper velocity we needed. And then, of course, this second burn is so important for the velocity we need to get in transfer orbit.
Awesome. So the Dominator punching a hole in the sky, as Dr. Zurbuchen said. So we will send it back out now to the main desk and be back with you in just a minute to catch that second burn. Daryl?
All right, thank you very much.
Thanks so much, Joshua. Joining us now to talk about how special these missions are is Dr. Michael Watkins. He's the director of the Jet Propulsion Laboratory in California, which planned Perseverance's mission to Mars. That is my home center. Thank you for joining us, Dr. Watkins. My pleasure. So we have so many great questions for you. Why are missions to Mars unique?
Well, you know, I think they're unique for 2 ways. I mean, one is just Mars. You know, it's been in our imagination for centuries. You know, it's a place that looks like the Earth. It looks like it could be home to us. It looked like it was once home to to what could have been life. And the fact that we can get there, and we can get there every couple of years, and we can send missions, and we can build on those missions, and you know, you can learn from your mistakes. You can learn from your successes. One of the things I like to joke about is, you know, we say Perseverance looks like Curiosity, but the people who built them are the same. They look even more like each other. And so they, you know, so a lot of our folks worked on Mars Pathfinder, they worked on Spirit, Opportunity, they worked on Curiosity, and now Perseverance. And that, you know, that history, that group of folks, they're just world leaders, and it's why we're successful.
So you oversee the Jet Propulsion Laboratory in California and doing incredibly complex work. Why are these robotic missions so hard?
You know, they're hard because you can't really see what's going on. You can't use your human responses, right? You know, you're used to driving your car and you see what's happening, and you know, you turn the wheel. In this case, you know, we've got to tell the rover, we've got to prepare the rover to do a lot of that stuff on its own, right? And so we've got to understand Mars, we've got to understand how the rover works, and we've got to put all that together into a machine that can function more or less without us. Mm-hmm. So we talk to it once a day, and we say, you know, how are you doing, and go over there and do these experiments, and then it's got to do that. So, you know, we kind of give it its intention, but then it's got to do all those activities by itself, and that's a challenge. And the further away from the Earth you get, the harder it is. So you get out to Saturn, you get to Europa, you get beyond, and it becomes harder and harder.
Yeah. Real quick, one question to wrap up. You've been in touch with the folks out at JPL. On air, there was an earthquake that played out. It was a 3.9 magnitude. How is everybody doing? How's your team?
They're doing great. You know, our view is just Pasadena. It's just the Earth being excited about going to Mars. So it was a very minor earthquake. We have them a lot in California. Okay. You know, maybe it's like hurricanes here or something, but it's tropical storms here. But it was a very minor event, and everything's fine, and we are on our way to Mars.
Okay, so a little rumble here in Florida, some rumble in California. It works out great. Mike Watkins, thank you so much. We appreciate you joining us on the broadcast.
My pleasure. Thank you.
All right.
Awesome. We will have that conversation with Zena Cardman coming up, which I'm super excited about.
That's right.
Yeah. On the other side of the Centaur burn and spacecraft separation. We'll also highlight 6 major technologies that NASA's focusing on over the next decade, including the critical energy needs for such missions. But with that, let's turn our attention to the next operational steps. Joshua, are you there?
Yeah, Moo, we're here and we're excited. We have a fuel pre-start call just coming in. We are getting ready to hear the call for this second burn of that Centaur RL-10 engine. Again, Mick, explain what this second burn is for.
So as we talked earlier, the second burn is really to get us that velocity as we head into that transfer orbit, right? Centaur in Mars 2020 will head into that solar orbit on its way with the proper velocity. We will then get ready to separate Mars 2020 on its way. And I'm hearing that settling is done, and we have main engine start.
There we go. Awesome. And again, that animation there being driven by actual telemetry data coming from that rocket. So that's a phenomenal sign. And again, I think that it's tough with these images. Perspective and scale are so important. This vehicle is in Earth orbit. It's not near anything, so you can't see the acceleration of what's happening right now. But for 8 minutes, it's going to be picking up speed.
Yeah, this is the burn that gets us really moving in the direction we need to go, that fast velocity that we need to get out of our park orbit and head on our way to Mars. Of course, Centaur and Mars 2020 are still together.
System is in closed loop control
we're hearing
as well.
everything is looking nominal on this fire so far. Main engine start was good, and the firing is going well, nominal, as we see in the animation there.
Fantastic. So this is rocket science, and it's not easy. We actually want to bring in now, we have a special guest. This is Dr. Denton Gibson, excuse me.
Yes.
He is a rocket scientist. His official title is Senior Vehicle Systems Engineer. Denton, how are you doing?
I'm doing well. Thanks for having me.
Yeah, did you enjoy that? Obviously, you got to kind of spectate. A lot of days, you guys sitting on console, you have to kind of focus on your computer, but you got to see this one today.
Oh, yes, and it was a beautiful launch today.
Yeah, nice sunrise. Hey, tell us about your role with LSP. I was not making up things when I said you're a rocket scientist, but what exactly do you do?
So as our role in LSP, as a vehicle system engineer, we are the engineering team lead for a lot of the rockets that we launch our science missions on. And we are responsible for the oversight and insight into these launch vehicles for the NASA.
That's awesome. And I know in the past you've supported a variety of vehicles. Tell us a little bit about the vehicles that you have supported and the ones you're focused on today.
Yeah, so some of the vehicles I supported in the past is the Delta II, which was a long-time workhorse for our science missions, as well as the Pegasus and Taurus/Minotaur C. And right now I've been focused mainly on the Falcon 9 and Falcon Heavy.
Yeah, awesome. So obviously not focused on the Atlas V, but a lot of that experience and the process is the same. I want to take a moment to pause and say Denton's there at Hangar AE. That's the NASA Launch Services Program's hangar. They're very proud of that. We call it the telemetry center of the universe. That's where the data for today is flowing. But I wanted to also ask you, is the process the same for all these vehicles? When we talk about the telemetry and these sort of processes of getting from Earth to Mars, does Falcon 9 experience translate to Atlas, or are they completely separate?
So the overall process for many of these launch vehicles are the same, whereas you ship stages to the launch site and assemble the launch vehicles by stages. So in that sense, they're the same, but there's a lot of differences between the launch vehicles that may change that process a little bit. But in general, the processes are the same.
Yeah, and Joshua, I was going to say, Denton, I work with Denton quite a bit over the years, and he talks about the different vehicles he's worked on. But Denton is one of my senior vehicle engineers in LSP, and so although he's not totally supporting Atlas V today, he does have experience with Atlas V, and as he said, things are very similar. So using his experience, we're able to train and bring on new generation of engineers, and Denton's been a huge part of that to allow us to grow our bench, if you will, to start working commercial partners.
Yeah, awesome. So Denton, tell us a little bit about kind of what's involved, what goes in behind the scenes, what's the rocket science of going from Earth to Mars, this maneuver to go into solar orbit.
Yeah. So a lot of the things that happen behind the scenes it's a lot of analysis work done by our analysis teams. I mean, it's months and months of analyses that are performed based on the orbit insertion, the performance of the launch vehicle. A lot of modeling and simulations is done to be able to get to this point to where we can transfer from Earth orbit into solar orbit.
Awesome. And obviously, you're a rocket scientist. That's for a lot of people, that's like the pinnacle. That's like, hey, I want to be a rocket scientist. So where do you go from here in your career? Because obviously, I'm sure there's lots of things that you'd like to go and accomplish.
So, going from here, I mean, one of the coolest things about this job of working in the Launch Services Program is working the launch, right? I mean, who doesn't love a launch, and who doesn't love working launches?
Yeah, we love them. We love them. Excitement this morning, right, Denton? We got to see that's what it's all about.
Of course. So, one of the ideal jobs would be a launch director, because you get to work all the launches. I mean, how cool is that?
No, yeah, that's true. And I guess you get to, is it right to say you call the shots, or is it that the buck stops with you, or how would you say that?
I'd say the buck stops with the launch manager. As today we talked, right? Omar Baez is our launch manager for Mars 2020, and he had to poll the team and make sure everything's ready to go. So the buck does stop with him right there on today's launch. And as Denton says, I think there's a lot of people that would love that job, and Denton's definitely looking at that next step. So I guess we need to give Omar and his assistant launch manager, Tim Dunn, a heads up.
Yeah, there you go. Dr. Gibson.
Dr. Gibson is
Up
on the
and
way.
Yeah. Awesome. Well, Dr. Gibson, before we let you go, give us a real quick snapshot. I know you have a mission coming up later this year. What are you working on?
So we're supporting the Crew 1 launch coming up. So we're helping commercial crew out with that one, as well as Sentinel-6 as far as the LSP missions that's coming up later on this year. And so we're excited about that one.
Yeah, a ton going on. Dr. Gibson, appreciate you. Thanks. And I want to take a special moment on the commercial crew note. note to comment. We've got a big day coming up.
Yes.
Pending weather. There's a tropical system that might kind of get in the mix here, but we have a tropical system that could create some problems. Otherwise, we've got Bob and Doug from Demo 2. They're coming home on August 2nd.
Yes, I was going to say, Joshua, that's important for us also in LSP. Denton was my lead VSE along with a few others that are in the group that worked that mission with the Commercial Crew Program. And so it's really important for us to be able to support other programs within the agency to make these things happen. As we launch Mars 2020 today, which is another step for us getting humans to Mars, right, is getting humans launched off of Earth soil was a huge step for off of American soil.
Yes.
was a huge step for us.
Yeah, and so talk about that really briefly with LSP. Obviously, Denton there, appreciate him and his contribution, and you working towards Commercial Crew, but also supporting Artemis, which is also part of that path of getting humans to Mars someday. Artemis is about learning to live on the moon to sustain a presence there with the eyes on Mars. So how is LSP supporting even Artemis?
Yeah, one of the things there is the Gateway program, right? Deep Space Logistics that is working a lot of that. And so LSP is in the works of supporting Gateway and helping them work with the commercial partners that are providing the rockets for those kind of missions that are out there and future things. One of the cool things about working with the Launch Services Program is that we work with all of our commercial partners, SpaceX, United Launch Alliance, Northrop Grumman Space Systems, and of course some up and comings. You may have heard some, right?
It is a growing
Origin.
field. Yeah.
It's definitely a growing field in the aerospace industry, and LSP takes pride in working with those commercial partners to figure out what we can do for NASA and the country.
Awesome. Yeah, it is an exciting time for spaceflight. The commercial spaceflight industry is booming. There's always new things happening. If you keep an eye on the news, you will see new things. We're getting word now that the engine cutoff here should be happening momentarily. Once we see that happen, we'll have roughly, I believe it's 5 minutes until we actually see the spacecraft separation occur. So we're going to stay with you through that, but want to kind of just preview that for you, that hopefully on screen here, you should be seeing that engine cutoff, and that's completely expected. That's a nominal operation, as you say, Nick.
We'll hear from Jesse Gonzalez, who's looking at the launch vehicle telemetry and watching the animation there. So let's listen in for Jesse here.
And there's the call, and there's the animation, again, modified based on data. So
shutdown parameters.
Let's talk about communication for a minute, Nick, because it is not an automatic thing to just shoot information at Earth and have that be usable. So how do we go about communicating not only through launch, but on the way to Mars, and then once we're at Mars?
Yeah, so the important thing this morning is when we lifted off from Complex 41 here at Cape Canaveral Air Force Station, we had ground stations that were looking at the launch vehicle and tracked it all the way to provide data. Once we got onto orbit after stage separation, you heard a call out for TDRS, the telemetry network that NASA owns, which, by the way, is also used for the ISS and will be used hopefully for the landing with Doug and them.
Yes.
So getting off the ground today was great because we could deconflict some of that TDRS usage, right? But TDRS is very important for us to be able to get the telemetry from the launch vehicle back down to Earth here. And then, of course, when Mars 2020 separates and it gets on its way to Mars, then the JPL team will take advantage of NASA's Deep Space Network, which has been around for a long time, to be able to transmit commands and data back and forth to the Mars 2020. So it takes a lot of folks to work those, and the TDRS and Deep Space Network are very important to not only the science missions, but human space flight also.
Yeah, and I think the coordination of that is something that people don't get a chance to understand much, because as you said, we're using TDRS for crew return, we use TDRS for space station, and TDRS is not an unlimited resource. We have a good number of TDRS satellites in orbit that help us do these things, but it is a coordinated effort across the globe, because we even have ground stations in Australia, I think. Yeah. Where are all of our ground stations even?
We have ground stations everywhere, not only here in America on the West Coast and East Coast, but then you get into the South Africa area, Australia, you said. We have several ground stations that catch up different things for missions. But, of course, in orbit, TDRS and the Deep Space Network are very important. And as you said, there's not an unlimited amount of resources there in the TDRS network. So we have to coordinate those things within the NASA agency and with our commercial partners when they're used for our launches. And again, that's another part of what NASA does as an agency.
Yeah, so just on that note, kind of thinking about around the world, currently this spacecraft is roughly over the South Indian Ocean. So that's just thinking about how fast we're moving, just the amazing world of spaceflight. It's just hard to put into words sometimes. Of like we're literally flying around the Earth and we're already halfway around it. And so I want to talk actually about planetary protection some more. I know we heard about that a little bit from Moo, about how they're working to protect Mars from contamination, so to speak, just putting things there we don't want. And we have to consider that, or ULA has to consider that when they're flying to Mars and delivering the spacecraft.
Yeah, it's a combined team. ULA, JPL, LSP had to look at that for when we get ready for spacecraft separation here in about a minute, right? One of the things we talked earlier is that Centaur and Mars 2020 are on the same path towards Mars right now. So once we separate, Centaur will do a CCAM maneuver, what we call a contamination and control avoidance maneuver, and then blow down what's left of propellants in its tank. And by doing that, we have now put Centaur on a different track so that it will not intercept Mars or interfere with Mars 2020 at all for approximately the next 50 years.
Yeah.
And that took a lot of work by the JPL team and the launch team to make sure that would happen. So again, another planetary protection maneuver that had to be done.
Yeah, and I understand from the telemetry experts in LSP that this rocket actually, after the second burn, is not actually aimed straight at Mars for that reason. It's actually aimed slightly off of Mars. And so Perseverance, Mars 2020, will redirect itself just slightly. We're not talking about over 7 months. A little bit of difference here makes a lot of difference later.
Absolutely. And Josh, we heard Jesse telling us that Centaur is spinning up. This is the maneuver right prior to spacecraft separation, where we get into a slight roll to give Mars 2020 some
stable Centaur tank pressure,
stability.
Very good performance from the RCS system, and stable indications from the avionics systems as well.
So RCS there, the reaction control system, that's those small, the series of those small engines that you see firing around the spacecraft. Those are used for that in-flight operations that they need. The rolling activities, as Mick's saying, is basically providing stability to the flight of Mars 2020 as we go forward. Tell us about actually...
And we have successful separation of Mars 2020 with the Perseverance rover.
There we go.
Awesome. We got some nice applause there. That is a big moment. We are hoping to get some live video back from that because of the time delays with communicating with things in space. We don't have it at this instant. We're hoping we'll get to see that here in a few minutes, and we'll bring that to you if we do. But tell us about the separation maneuver, because the apparatus, the actual... It's a really simple design.
It's a separation clamp. We'll talk about that in a minute, but as you see on your screen right now, you see the Mission Director Center where Omar Baez and the team are. And Josh, you and I joked about this a little bit earlier, but with the pandemic and everything going on, the teams have done a great job. Normally, spacecraft separation.
2020 with the Perseverance rover, the Centaur will now perform its standard propellant blowdown sequence to inert the vehicle and complete today's flight after completing its CCAM avoidance maneuver. This will conclude today's commentary of the Mars 2020 mission. This is Atlas Flight Commentary signing off.
So that's the end of ULA's job for today.
Jesse Gonzalez did a great job with the ULA commentary this morning. But what I was saying about the Mission Director Center is normally we would see a lot of clapping, a lot of hoop-hollering, a lot of high-fives, handshaking. But with the pandemic and everything, people are staying their distance, taking the guidelines seriously, wearing masks with this. So we saw a lot of air high fives, right?
Yes,
and stuff.
absolutely.
So that does not take away from what the team is, how excited they are. They have done a lot of work to get to this point, and that seeing spacecraft separation is awesome. So, but
and throw all on top of all that, 2020 was like, here, have an earthquake,
right?
So it's just we did it. Like we're most of the way there, not there yet.
Yeah, as you heard Omar earlier in the broadcast say, a lot of us when we started this, when the pandemic started, we kind of thought Mars 2020 might be Mars 2022.
Yeah.
But Mr. Bridenstine and the NASA agency decided to move forward. The teams found ways to do this. As we heard, they were disciplined, they were focused, they were courageous. And all that played off today with a successful launch at 750 and now spacecraft separation, Mars 2020, Perseverance and Ingenuity on their way to the red planet.
Hey, we're going to wait for acquisition of signals. Stay with us. But really fast, Mick, tell us very, very quickly about this mechanism, because we teased it.
We teased it, yeah.
How do these things separate?
So the separation system is called a Marmon clamp band, actually designed earlier by Karl Marx, one of the Marx brothers. Very simple design, but it has some spring systems in it that once the signal is sent and the bolts release the clamp band, the springs basically just give just enough force to push the spacecraft off the front of the vehicle.
Awesome. And again, hopefully we'll see that video here momentarily. But for now, we're going to send it back to you and check in for one final time in a little bit with the folks here at ASOC. But Daryl, back to you.
All right, thank you, and great job, both of you, Joshua and Mick. It's always great to see Mick explain that springs are what's getting us to Mars. All right, so we've got our second burn underway. We've been flying for right about an hour, and as you just saw, spacecraft separation went well, and so that's fantastic. We can now say that Perseverance is officially on its way to Mars.
What a beautiful thought that is. And while NASA has been tracking the spacecraft since launch with its tracking and data relay satellite system, I know the mission control team at JPL is turning their attention to the next milestone, and that is ensuring that the array of communication antennas known as the Deep Space Network, or DSN, begin to receive a signal from the spacecraft flying the Perseverance rover to Mars. We expect to see the teams acquire the signal close to 9:14 Eastern Time. Though, as you saw, the spacecraft separation has occurred in the shadow of the Earth and out of line of sight of the system, so this could take a bit longer than estimated.
All right, and so finding life on Mars won't be as easy as you might think, and we talked a little bit about that. Here to talk about that and more is NASA astronaut Zena Cardman. Zena is here to join us, and we're so glad that you're here. Thanks for taking the time. First of all, your reaction to that launch.
Wow. Every time it takes my breath away. I had actually never seen a launch before until I got this job as an astronaut, and now I'm very lucky to have seen 3. And every single time, it just makes me feel so much emotion.
And kind of talk us through, I mean, it got up quick, right? So as you were watching it, you feel the rumble?
It did, yeah. First you see it go up, and then you feel the rumble as the sound travels to you, and you can really feel it in your chest. It's amazing.
Very good, very good. Talking about astrobiology now, you have an amazing background. You've searched for signs of life in some of the most extreme environments on Earth, the Antarctic, the Arctic. So you're used to looking for these biosignatures. What are your thoughts about this rover searching for signs of life?
Yeah, we have a lot of experience looking for signs of life in unusual environments here on Earth. So if you take a look at Mars today, it's very cold and very dry, and we have some places on Earth that are actually a lot like that, so places like Antarctica or deserts. But if you want to look for signs of ancient life that existed billions of years ago perhaps, when Mars looked maybe a lot more like Earth does today, you have to know what those signs of life left behind in the rock record, because microorganisms are very tiny and very soft, so they don't leave a fossil the same way a dinosaur would leave a bone or a footprint. So instead we use these chemical signatures.
Daryl's dreams is shattered again. We told him there's going to be no dinosaur bones on there. He really wants them.
Something wiggling around, but no.
So why do we need to go to the moon before we go to Mars?
That's such a good question, because we've been to the moon, right? But we haven't been to the moon to stay. We really don't know how to live off of Earth on another planetary body, and we really need to figure out how to use resources, use tools, especially if we want to do geology on Mars. The tools that we use here on Earth are going to look pretty similar, but they might not work quite the same way. And because the round trip to Mars is so much longer than the round trip to the moon, when we go, we want to do it right.
Very good. And how do you like that rover behind you? Huh?
Oh my gosh,
safe?
I love it.
Yeah, it's great. Hey, I want to ask you some social questions now. These
Absolutely.
are some from our audience who have been watching.
Oh,
so
great.
We appreciate you doing that. Our first question comes to us through Facebook. Thomas asks, will Perseverance land to investigate the landing site for a future manned mission in the same location?
Yeah, that's a really good question. I think one of the most interesting things about doing a mission to Mars is choosing where you're going to go.
Yeah.
Because, you can imagine planning a mission from Mars to the Earth, and if something landed in Utah versus landed in the ocean, your vision of Earth might be quite different.
Mm-hmm.
So one possible approach is taking a human mission and going back to somewhere where these rovers have been already, or maybe we'll decide to explore somewhere new. I have no idea yet, but I can't wait to find out.
Awesome. It looks like we have another social media question from Twitter, from Huda. Do you think that in a few years we'll be able to send astronauts to Mars in a safe way if we are able to send a rover like Perseverance to Mars in a safe and amazingly planned way?
I hope so. We won't go until it's safe for humans for sure, and we're not going until it's a round trip. But actually part of this mission, of course, is a round trip, and so we will eventually learn how to send a rocket to Mars and then have something lift off of Mars and come back.
Well, Zena Cardman, thank you so much for being here. You did a fantastic job. You were a great guest, and
Thank you
glad
so
you enjoyed
much.
the launch.
Oh my goodness, it's impossible not to.
No doubt. All right,
Thank you both.
Now, as you can imagine, there are a lot of systems to develop and prove out as we prepare for sending humans to Mars, as you just heard. Here now are 6 technology disciplines that are critical to the success of our future explorations. NASA's first Mars rover were powered by solar energy, but dust storms caused issues by blocking much-needed sunlight. So NASA upgraded to nuclear batteries provided by the Department of Energy. And joining us now is the Assistant Secretary for the Office of Nuclear Energy, Dr. Rita Barnwell. Thank you so much for being here.
Great. Thank you for having me.
First
Excited
of all,
to be here.
how did you enjoy the launch?
It was amazing. Absolutely amazing. So fortunate to be able to be here and be invited to watch it. I'm just giddy.
Had you ever seen one before?
No, I hadn't. It was my first one.
And what did you feel as you were?
It was, you could literally feel the launch. So it was very exciting.
Very good.
Yeah.
So it's really interesting. When I saw this segment, I was just fascinated by the whole nuclear part of this. This is right in your wheelhouse. So explain to me, how did the Department of Energy get into the business of making nuclear batteries for space exploration?
So space exploration requires power sources for the long-lived missions that we need for this type of activity, for heat and electricity to be provided to the spacecraft and the scientific instruments. And nuclear energy can certainly provide that power. One source is the radioisotope power system, RPS. Part of that RPS is the radioisotope thermoelectric generator, and RTG. I know that's a lot of acronyms, but you got a decoder ring, so I hope you're good there. A space nuclear power system that converts heat into electricity without any moving parts. RPSs work by converting heat from the natural decay of radioisotope materials into electricity, and that's what we have up on the rover that just got launched this morning. It consists of two major elements, a heat source that contains a radioisotope fuel, mostly plutonium-238, and solid-state thermocouples that convert the plutonium's decay heat energy to electricity. DOE developed several generations of nuclear space power systems that can be used to supply electricity and use the excess heat for a variety of other space applications. This one that was launched is called the Multi-Mission RTG, and it was designed with the flexibility to be able to be operated on planetary bodies with atmospheres just like Mars, as well as in the vacuum of space.
It's amazing the longevity of that battery.
Yeah, I heard it could last up to 14 years.
Right.
Will it actually last longer than that duration?
It can, and actually right now it was 17 years, 3 years here, and then 14 years out in the mission itself. So we're very excited about that. That's one of the benefits of powering this mission with nuclear energy. The RPSs that are currently powering Voyager 1 and 2, that are exploring the extremes of our solar system, also are being powered by an RPS that has lasted for 43 years.
Wow.
And
That's a long time.
That's a great extent of time.
Yeah.
The MMRTG is essentially, it's a nuclear battery, like you said, and it contains only 10.6 pounds of plutonium dioxide fuel, and it provides 2,000 watts of thermal power. It's similar, the material that's used in this is similar to what was used in the 2 Viking spacecraft that landed on Mars in 1976.
Wow.
So this technology has been around a long time, and it's well proven.
Yes.
Dr. Rita Baranwal, we thank you very much, the Secretary, or Assistant Secretary for the Office of Nuclear Energy. Thanks for coming out. We're so glad you enjoyed the launch, too.
Thank you for having me.
You're welcome. All right, here's a statistic you might not know about. Missions to Mars, roughly half of them actually make it there. Imagine that. But right now, we know the health of the Mars 2020 rocket is good because it's sending back a stream of data to our telemetry nerve center here at the Cape. Let's go back now to Joshua Santora to learn more about that. Joshua?
Yeah, thanks, Daryl. So we talked to Dr. Denton Gibson, who is one of the guys that works behind the scenes, but there is a group of folks that work behind the people behind the scenes, and Jessica Connor is one of those. She's coming to us now from the same Hangar AE location. Jessica, thanks for joining us.
Hey, it's a pleasure to be here. Thanks so much for having me on.
Yeah, so tell us about what you do to help make all of these activities, and as Daryl mentioned, the telemetry happen. What do you do for, what's your role for LSP?
So I work as a mission communications engineer for LSP. That means that I'm getting the video, data, and voice requirements from the spacecraft and then ensuring that they're able to go ahead and perform these operations once they actually get to pad phase.
Yeah, Joshua, I was just going to say Jessica's one of our wizards. You said behind the scene within the launch services program as engineers, we depend on our folks at AE to make sure that we get everything we need to do our assessments as engineers. So they make everything possible there.
Yeah, absolutely. So Jessica, tell us a little bit about how you get the data back and then how it's utilized out to the team.
So while it's on the pad, we go ahead and get that data through the umbilical lines, and then that goes ahead and gets back to the engineers, and they're able to provide fleet insight based on the data that they get from the consoles.
And can you tell us about how long you've been working this mission? People probably don't understand how much time goes in ahead of time behind the scenes to make these missions happen.
So I've been working for about 2.5 years on this mission. About 2 years out, we start working with JPL to go ahead and get those requirements, and then we've been working with them since to go ahead and get processing video, and also being able to talk back to JPL, being able to talk to headquarters and stuff like that.
Awesome. And so what's been the biggest challenge for this mission? I know that this mission's presented a lot of unique challenges for all of our teams, but for you, where has that challenge lied?
So we have a ton of experience from different mission comm engineers from the past. And so the most unique thing about this mission has been our treatment of COVID. And it's amazing what we've done to go ahead and keep the control room safe for all of the people on console, and to go ahead and launch this mission on time and successfully.
Hey, listen, and we did it. We have the data coming back, so that means that I think that means you did your job really well today.
I would say they did their job great, Joshua. They found new ways, as we talked earlier with the launch team, finding new ways to their stuff. The folks out at Hangar AE also found new ways to make sure that all the engineering team could perform their fleet's insight assessments and support today's launch. So that team out there has done a great job. They actually make us in engineering look good. So we appreciate all the work you guys do, Jessica.
Yeah, awesome. Jessica, congratulations. Job well done. Thank you for joining us for this interview today.
Thanks.
All right, so Mick, things are pretty quiet now, and that's expected because we're just hanging out for the signal acquisition. The time there is the estimate based on the pre-launch data.
Yes.
Right now, we're actually in the shade of the Earth, so we're behind the Earth, and so we'll come out of that at some point shortly, and then hopefully acquire that signal because there's some solar arrays that have to play in here. So still kind of some, I don't know, tense is the right word, but we're anxious still.
Yeah, I would say we're anxious. We're focused still, as I like to refer back to what Tori said earlier, right? Focused and disciplined. Even though it's pretty quiet right now, we have had spacecraft separation, which was a huge milestone for the team, an exciting time for us at NASA, ULA, JPL, the DOE, and our United States Space Force family. But the team is still sitting on console. They're still following their procedures. They're still performing everything that needs to be done as we await the acquisition of signal. Some of the things that are going on here behind us is ground securing and everything here at the complex to make sure we can safely enter and do the work. So
yeah,
a lot of work still going on.
Yes, and we're going to send you back to Daryl because we need to check in and talk to the folks who are going to be getting that data back. So Daryl will check in for one last thing in just a few minutes.
All right, thank you very much, Joshua and Mick.
Yeah, we are getting closer to our final critical milestone for today's broadcast, acquisition of signal. That will mark the official conclusion of the launch efforts by the LSP and ULA teams. I know my colleagues at JPL have been eagerly awaiting the first moment to see the Perseverance signal show up on the screen.
And it's exciting.
Yes, it is.
It's exciting when it happens.
Yeah.
Our mission managers are expecting that signal about 80 minutes after liftoff, so that's going to put that right around 9:14 a.m. Eastern time. So let's go back out now to JPL in California, where things were shaking and rattling a little bit. Raquel, how does this acquisition of signal work?
Okay, Daryl, when it comes to making a long-distance call, it's hard to top NASA's Deep Space Network. It's the largest and most sensitive scientific telecommunication system in the world, and right now it's waiting for Perseverance rover to phone home and let us know it's heading to Mars. And speaking of dialing in, Philip Baldwin joins us from his home. Philip is part of NASA's Space Communications and Navigation Program, and he's here to tell us how we communicate across the vastness of deep space. So, Philip, Mars is several million miles away from Earth. How do we get signals back and forth between the two?
Well, Raquel, we receive signals every day on our cell phones. And you can imagine driving out into the countryside and you're farthest from the nearest cell phone tower. And you look down at your cell phone, you see one bar, a very faint signal. And as you mentioned, Mars is very far away, so you get a very faint signal, very much less than 1 bar. And so thankfully, we have on the ground from our Deep Space Network managed out of JPL, very large antenna dishes that can detect that very faint signal. You're talking about a signal that's basically like an incandescent light bulb and receiving that from millions of miles. We have 70-meter antennas and 34-meter antennas. A 70-meter antenna is about the size, to give some context, about the size of a 20-story building. So very large systems that can detect that very faint signal.
Great. And the Deep Space Network also communicates with all of our other missions beyond the moon. Now, how far have we gone into space?
Well, our Voyager missions are the farthest and fastest human-made objects that exist. Voyager 1 is nearly 14 billion miles away from Earth. It takes almost 20 hours one way to communicate to it. So once again, you can think about that light bulb. Could you imagine turning on a light bulb or a light switch and that light taking 20 hours to get to your eyes? And so basically, to communicate to Voyager, we send a command saying hi. Takes 20 hours to get there, and every 20 hours to receive a response from Voyager. So very far away. Thankfully, Mars is not as far away, as you mentioned, several million miles, not billions. So it takes not 20 hours, but it takes about 7 minutes. So it's a little better situation there.
Wow. So what does it take to add the Perseverance mission to the Deep Space Network?
Well, it's a lot of pre-work before the launch. We test with the launch vehicle, we test with the spacecraft, we test with the rover. We test over and over again to ensure that when it launches, when the spacecraft separates, when it lands on Mars, that we can have confidence that it will be able to establish a communication with us back on Earth. That's very important, and we instill that confidence by testing and making sure we have a lot of testing up front. And the payoff comes when we see those great, awe-inspiring images from Mars. And so a lot of testing happens up front, and a great team that works on that.
Great. Now, getting an acquisition of signal is a very significant moment. Can you tell us how it works and what we should expect to see for this mission?
Yes, that's a very important moment. And sometimes you'll see a spectrum graph that's a couple squiggly lines on the bottom, and what you expect to see is a peak in the middle come up, and that's what you call the carrier signal. And the carrier signal is described as a carrier because what it does, it brings in the signal. It carries the signal to us. Therefore, we can see that signal and know that we're receiving data. And basically, we see the carrier signal, but after that, we have to decode what the signal's saying. And hopefully what we're seeing is that the spacecraft is saying, hey, I'm doing okay. I'm on my way to Mars, and I'll see you there in 7 months. And so we expect to see that signal, and then we'll decode it and be able to get the health and safety of the spacecraft. But also what we'll also look out for is how to track it. So once we have the signal, we'll lock onto it. We'll move our very large antenna dishes, and as the Earth spins, we'll track the spacecraft around the globe. This is a global effort. We have our station in Canberra, Australia, and Madrid, Spain, and Goldstone, California, who all will be part of this tracking as the spacecraft goes to Mars. So very exciting time, and we're looking forward to hearing from Perseverance shortly.
Great. Thank you, Philip. Now, we are just a couple minutes away from the first opportunity we will have to see if the Perseverance signal on the Deep Space Network is up on our screens. That moment brings us one step closer to Mars, but we have many other milestones to hit over the next 7 months, and I'm with Perseverance's Chief Engineer, Adam Steltzner, who will tell us what's in store for the rover. Adam, what should we expect to see next?
Well, Raquel, we are... After we acquire signal, we have left the building. We are on our way to Mars. We're no longer in orbit around Earth. What will happen next is we will start our cruise phase. It'll be about 7 months before we make it to the Red Planet. We have a set of planned trajectory change maneuvers that we do during cruise to adjust our targeting. In fact, we're targeting to miss Mars right now. We're on the way, general direction of Mars. But in order to make our Atlas Centaur, which threw us in the direction of Mars, not run into Mars, we're on a missing trajectory, and we'll do TCM-1, which will target our impact with the Martian surface in a few days. So we start to monitor the spacecraft, make sure it's healthy and happy, and tweak its trajectory to be right on target by the time we make it to Mars.
Great. Thank you so much, Adam. And right now we are just a minute away from the acquisition of signal. So let's pause for a moment and watch our teams at work.
Today's flight will be waiting for indication of acquisition of signal. Ace copies.
20, MEM, RegiSign, report initial acquisition.
There we go. That's it.
Copy that, RegiScience.
Flight nav.
Go ahead, Nav.
We're seeing one-way Delta.
34, US. Didn't copy, Nav.
Yes, sir. We see AOS at 131531.
Ace copies. Thank you.
A little bit there, Dad? Yeah. Very funny to do the timing. About to follow my contingency procedures.
Flight Telecom, I was about to pull up my contingency.
We now have an acquisition of signals. The rumbles now are of claps and cheers, and it's an amazing moment. And the years of blood, sweat, and tears from every person who worked on this mission is now realized as Perseverance makes its way to Mars. Now, if we still have Adam here, Adam, I want to know your reaction to getting the acquisition of Signal.
Well, Raquel, it's very nice to have the spacecraft in a safe, separated, on its way to Mars. Nav looks good. We are hearing from the spacecraft. That was the only question. And it's not really much of a question, but it's just nice to have that confirmation. Our launch process is complete. The vehicle's on its way to Mars. And so the next chapter in Perseverance's mission can begin.
Great. And what are you looking forward to next?
I'm looking forward to, ideally, a very quiet and boring cruise to Mars as we prepare for the never boring and always stressful entry, descent, landing on the 18th of February.
Great. Thank you so much, Adam. And we hope you tune into our coverage of the landing happening on February 18th, 2021. Joshua and Mick, we here at JPL would like to thank you and the entire Launch Service Program and United Launch Alliance teams for all your amazing work today and all the work you do every day to make a launch like this possible. Now, Joshua, back to you at the Cape.
Raquel, congratulations to you and the team over there. Obviously, JPL, I think Adam's response is kind of what you'd expect from Adam of like, hey, check that box, but we got a lot of work to go.
Yes, yeah. I mean, the work here for the launch team, exciting day.
Yes.
We got this done. Our portion of this is done. Adam and the team now have Mars 2020 underway, and they've got a lot of work in front of them, too. And hopefully it is a quiet 7 months, and they get ready to go. But we are so excited to be able to perform this for them as our JPL customer. I know Tori Bruno and the ULA team are excited as well, and I just can't be. I can't be more excited about how this went.
It feels
morning.
good.
Yes.
Hey, before we sign off today, we want to check in with the NASA launch manager, Omar Baez, to get some thoughts from him. Omar, kind of give us your response after seeing a successful process this morning.
Okay, so about a minute ago, we did get acquisition of the spacecraft Signal. That signifies that JPL's Deep Space Network has locked onto the spacecraft. It's on its journey to Mars. Everything appears to be going nominally for them. They'll get to check out the spacecraft now, do those checks that they need to do to learn how to fly that vehicle the way it wants to fly on its way to Mars. Pretty interesting. We separated them at approximately 25,000 miles an hour, and it's going to take a little bit of a couple of months to get to that February 18th landing date, which they're targeting. So it's an impressive amount of speed that we imparted to them, and that speed is what our job as Launch Services Program and United Launch Alliance is to provide that spacecraft. The heavy lifting now is on our partners at the Jet Propulsion Lab. To slow it down when it gets to Mars, up the parachutes, slow them down in the atmosphere, and extend that sky crane and land on Mars. So they've got a heck of a lot of work to do. from here on out. Today's count went beautiful up until the last 20 minutes. Started to get exciting with some of the assets on the range having dropouts. And then a surprise call from the spacecraft mission director that we had a small earthquake in California at Pasadena that the folks in the control room felt. But they never lost signal. And they came back to me and said they were ready to proceed. We were able to lock down the time we were after. Launched on time. Perfect launch from what I could see visually here in the control room. The orbital parameters look dead on. Our velocity is dead on. So we're on our way to Mars. There's no way back. So good luck to the Mars 2020 team. It's been a pleasure to be part of this. I've been with this roving Mars community since Sojourner, and through Spirit, Opportunity, and Curiosity. So it's a pleasure to be once again part of that little bit that becomes that club, that auto club of roving on Mars. And I just want to say I'm very proud of this team. This team has worked diligently to get here. It's hard enough to get to Mars, throw in COVID. Today we're dealing with a small earthquake, the threat of a tropical storm heading in our direction. It's just an immense amount of pressure on the team, and it's so relieving to be able to have gotten that mission off today on the first attempt. And with that, that closes the show for us.
Awesome. A big thanks to Omar. Appreciate him and his words. Obviously, a phenomenal effort from all 5 of our teams we talked about.
Yes.
So from LSP, congrats to this team. JPL, congrats to the U.S. Space Force. Congrats to ULA. Thank you to ULA for hosting us today. And then the Department of Energy. And a special thanks to a couple groups, the RADCC and the JIC. Those were 2 teams that were working behind the scenes for over 3 years to prepare for a contingency with the MMRTG.
That's correct.
Didn't have to exercise any of that work, which is what they wanted. Like that's
So
kind of one of those
they
things.
had a great day.
They had a great day. Yes, everybody had a great day. So Mick, thanks to you as well for joining me.
Appreciate it, Joshua. Thanks for having me again. I've always loved doing this with you. And again, excited about the Mars mission. As Omar said, our prayers and good luck with the JPL team. They've got a lot of work in front of them, and we're just so excited to get them on their way in a perfect launch and orbit today. So thanks again for having me.
Yeah, the countdown to Mars continues. That's going to do it for us at the ASOC for the launch of the Mars 2020 mission with the Perseverance rover. Daryl, back to you.
All right, Mick Woltman and Josh.